Welcome back. Last time we talked, we looked at indexing, we looked at referencing one character from a string, and then we also looked at substrings and slicing. In this video, we're going to look at comparisons. So the question is, can we use strings in Boolean expressions that return true or false? And right here, you will see that we're starting with comparison operators. Can we use greater than, less than or equal, not equal? Can we use that to compare two strings? Whereas here's how Python interprets strings. The textbook says Python compares string lexicographically. But what does this exactly mean? Every character in the string actually has an integer value associated with it. So there's a value for lowercase a, there's a value for capital A, there's a value for commas, there's a value for apostrophes, and all sorts of other characters. And actually, it's hard to remember the values of all of them, so you will see here that I gave you two links. Most of the characters that we use in the English language, the Latin alphabet, can be found in an ASCII table. Here's the example. Here's the ASCII table. Notice here that we have all the digits represented, we have all the capital letters represented in order, all the lowercase, we have backslash, we have colon, semicolon, greater than, equal, multiply, all sorts of characters that we use daily. Now, these are not all the characters we could possibly encounter, and actually Python 3 uses Unicode to encode characters. The ASCII values are a subset of Unicode. So for the Latin alphabet, all we need to worry about is the values in here, which again, you shouldn't memorize them. If you need to know one, you should just look it up. Any Googling, there's a link on Moodle that leads you to the ASCII table. But for characters in other languages, we have Unicode. So for example, a character in the Chinese language, which actually might be a word like cat, would also have an encoding for comparison purposes. So lexicographically also means that the characters are evaluated in order. So let's take an example here. Suppose we have a string 1 and we have Larry, Larry, in it, and the second string has lab, lab, and we're trying to see if the strings are equal. Of course, we can immediately see that the strings are not equal, meaning they're not identical. So only if the strings are identical, the equality operator will return true. Otherwise, what happens is that the characters are compared one by one. The first character from the first string is compared to the second character from the second string. In this case, they're identical, capital L. Then the second character is compared to the second character. They're also identical, lowercase a. And then we have here an R and here a B. R is not equal to B, which will return this false, and we can run this and see it, false. But also, if we want to see if Larry is greater than lab, we can print that too. That is true. That's because the value, the ASCII value or the Unicode value associated with R is greater than the one associated with B. Let's look at the table again. R is 114 and B is 98. 114 is greater than 98. We went character by character. The first character that is not identical, their values are compared. The value for R is greater than the value for B, so Larry is greater than lab. Let's do a few more examples. What if one of the strings is a substring of the second one? Would they show up as equal? Larry is greater than lab and Buy is not equal to buyer. That return true. Another example where there's some similarity. Some beginning characters are the same. Also true, because we got to the point where the different characters, the characters that are not the same, is R from the first string and A from the second string. R is greater than A. If we change it to a less than or equal, we will actually get false. Let's see, something even a little more complex. Ready greater than or equal to not ready. It doesn't matter here that ready is a substring of not ready, since they are compared in order. The first thing is R is compared to N. R is greater than N, so this is going to return true. Okay, now let's see. What if we compare same letter, lowercase versus uppercase? Which one comes first? Which one has the highest value? The lowercase one or the uppercase one? Well, it turns out in ASCII, the capital letters come first. So for capital Y, the value is 89. For lowercase y, the value is 121. So we're asking, is 121 less than 89? False. So uppercase letters come first, have the lower value in the ASCII table or in the Unicode table. What happens if we compare a string with the empty string? We don't really have kind of like an empty string here in our table. We have space, which is one of the first here at 32. Turns out that when it comes to the empty string precedes any other string under lexicographical order because it's the shortest of all the strings. So any other string should be bigger in ASCII sense than the empty strings. Can we use strings as input arguments for built-in functions like max and min? Well, so max usually returns, if you give it a collection of integer values, the highest integer. But turns out the situation is kind of the same with the string. It will basically return the character with the highest corresponding integer, with the highest ASCII value. So in this case, kind of like the letter that is the highest in the order in the alphabet, so that would be O. There it is. The max of hello is O. Now also, since we were talking about Boolean expressions, remember how we said that, for integer or floats, any variable that doesn't have the value 0 will be interpreted as true? Well, with strings, things are a tiny bit more different. Empty strings are falsy, meaning they return false in a Boolean expression. So here, if S is an empty string, and we want to say if not S, this would be the one that would evaluate to true, while if S will evaluate to false. So in this case, we are printing string S is empty, not S evaluated to true, because S evaluated as false. One last thing. Can we compare strings with other types? Here, integers. Can we say, is 4 greater than ABC? Let's clear this window so that we can see this better. We cannot. In Python 3, this is not possible. Basically, we get an error. The greater than operator is not supported between instances of integer and string. Basically saying you cannot compare an integer with a string. This concludes our video.